Hello and welcome to this Antonov An-225 tutorial series video. So, what are we going to be covering in today's video? We are going to be doing a quick flight from Leipzig to Frankfurt, and we're going to be using the in-sim checklist system and taking some cargo with us while looking at some basic features of the EFB. If you want a video to be a quick start video, that will also be available, and that will be the best video for you getting going as quick as possible. This is a little bit more in depth, and we're going to talk a little bit more about how and why we do things. Also, you'll notice this is kind of done in a one-take style, so the head cam's going to move around. It's not as edited as the other videos, because that's what we want for a tutorial video, to see where and why we're doing things. So, let's get on with it. You may notice that we're here on the world map. Why are we here on the world map, you might ask? Well, I think this is a feature that's actually underutilized by the enthusiast crowd in Microsoft Flight Simulator, and it's a great tool, and I cannot stress to you how much easier this will make flying the 225. So, let's start. We are going from EDDP to EDDF, and we want our departure runway, which is correct, but we don't want the arrival here. We want it to be the ILS 25 left, and then we can select the departure here as well. There it is. So we've got the 3 Bravo, 25 left, and the ILS approach runway 25. Departure-wise, it's going to be a takeoff and then direct en route, which would make sense. And here you can see it offers you different options for the route if you want to take it, but this one to me looks fine. If you don't see this route, you've got to make sure that you have high altitude airway selected. If you don't, then it will show you just direct routing like you would for a VFR plane. Now, that's our whole flight planning aspect done, and when we load into the simulator, the route will be automatically loaded into the flight management system. You can obviously do this manually if you want to, but I honestly recommend this the way to do it. It's really, really good. So let's load into the sim. Okay, so here we are in the flight deck of the 225. Let's quickly go over all the different positions that are available in the aeroplane so we can get a bit of an overview so you know what I'm talking about. Let's start off with the captain. So this is the captain's position. Above them we have the left side panel. And then above that, in the middle, we have the overhead. This is what's referred to the annunciator lights. So this big black box here is the annunciator lights. And below, this is the pedestal. Here, we have the first officer's position with the right side panel. Moving backwards, we have the navigation station, so the navigator station. To the left of them, we have the radio operator. Behind them, we have the electrical engineer, and to the left of them we have the engineer, so the flight engineer station. And that's it. So let's go back to the captain's position and start off using the checklist. So with the checklist, the first section is electrical power up. So let's go through each of these items, and what I do is I'm going to click on them, click the eye, and it will take you to the item. You can use the evaluation function, so this will read each item and will tell you what to click. But we're going to go through it manually so I can explain it a bit better. So, first of all, parking brake set. So you can see that toggles the parking brake on. It gets pulled back and twisted when it's in the lock position. Battery switches, auto. Now, there are 5 battery switches, and we want to make sure that they're all in the auto position. So, auto is up. So let's start there. So, 2, 3, 4, 5. So all 5 of them are up. If you select it to the down position, that's manual, middle is off. External power as required. We're not using external power, so we don't have to worry about that. If you want to select it on, it's available in the EFB, and then you simply select this to turn on external power. Fuel heater 1 off. We make sure that this is selected off. AP1 fire loop, turn it on. AP1 bleed, we select that on as well. AP1 master switch. Now we uncatch the guard, grab the switch, and turn this on. This turns on the electrical supply to the APU. AP1 start switch, uncatch the guard, and we press the button once, such as to click, and now the AP will start. There's a bit of a pause before it starts because it opens up the air intake, and then the fuel is introduced, and then it will start. So you can see here temperature's rising, and it's showing that it's starting here. And here we can see the N1 is increasing. Now we just wait for that to get to 100%. Okay, so here it is approaching 100%, so now it's on. And now if you want to, you can start the second APU, but you have to be aware, if you start both of them with low battery, you can actually drain the battery. You only need one to supply the electrical supply for the aeroplane, but just to show you the process again, we are going to start the second APU. So, make sure this is off, make sure that this is on, make sure that APU2 bleed is on, APU2 master switch, again, we click this to on, APU2 start switch, a similar process, we just select this to on. And now we just wait again for the second one to start. So now we're going to move to the electrical panel, which is here. And what we can do, which will help the electrical load, is we can turn on the left generator switch. So now the whole electrical system is supplied by the left generator, because I've just turned it on. And you can see it's available when you have this green light here, which says left APU gen on. So on doesn't mean it's on, it means it's available to be switched on. A bit confusing, I know. So if you see the green light, you also got to make sure that this generator is selected on. So what we're waiting for now is we're waiting for the right one to show the green light, to show that it's on, and then we can select it on as well. Okay, right APU gen on, and now we select it on. We can see the lights here. This shows that the APU is supplying the electrical system. So let's, for example, turn both of these off. And boom, you can see the batteries connect up and they start supplying the system. If we connect them up, then they take over. Makes sense, I think. APU right generator switch, we've already turned that on. External power. Now, if you had used external power, you would now select it off. It's not needed anymore. Rectifier toggle switches, we turn these on. And you can see that the electrical system gets powered up here. Transformer rectifier switches, we turn all these on. And now we're going to move away from the electrical panel. Instrument navigation switches, we make sure that we select every single one of these two on, and different parts of the navigator panel start to turn on. Careful, there's one hidden under here. Captain HSI. Now, pause for a second, I just want to do a bit of an explanation. Now, one of the main differences I find between the An-225 and let's say the A310 is the electrical system design and setup. Doesn't mean one is better than the other, it's just a different way to do the same problem. My best description is on the A310, think of it like you have one of those wall outlets. So you have a socket with about 9 different things plugged into it. You know, the sort of thing you use to power your TV, screens, all this sort of stuff. Now, when you plug that one outlet into the wall, you end up powering all the things that are attached to it, right? That's how the A310 works. That's why we only have 2 AC buses and a DC bus and all this sort of stuff. Best way to think of the Antonov is each item has its own plug, and you must make sure it's turned on, otherwise it's just not going to work. So if it's not on, it's not on. Even if there's electrical power to the plane, if the thing is off, it's not going to work. So that's why we now turn on the Captain HSI bus, so we're turning on the switch. Now we're supplying the radio altimeter. Now we're supplying the artificial horizon and the airspeed indicator, etc, etc. So I'm going to just go through these and click all of these ones on. And then we move across to the first officer's side panel, so the right side panel. Same situation again. And you can see there is quite a few of these, but this is a large part of the aircraft actually coming alive. Next, this is the light panel, so this is where the lights are, and we want to turn on the nav lights. Just the wingtip lights, the red and the green. I almost forgot what they were. Every single plane is the same, I should know that. Now we're moving on to the fuel, so we make sure that these are set in this position, so they shouldn't be off, but basically if they're not in the up position like this, then the engines will not start. They're an emergency backup. Now we make sure that the hydraulic pumps are all set off, and what I did there is I unguarded them all and just selected all of them off. You can re-guard them, so like this, if you want to. I'm just going to leave them unguarded as a reminder to myself. Now we come to fuel pumps, and there's a lot of them, and I want to just take a second to explain. If you don't want to get into the complexity of setting these pumps, the position that you load in, like this, is good enough for starting, cruising, and landing the plane. So you can just leave them alone. If you haven't messed with them, you can just leave them alone. This makes sure that the panel is set up correctly for this stage of flight. Or if you want to, you can just go through each one of these and it will say on. For example, you see it's on, then this one's on, and this one is off. And you can see these are engine 1, engine 2, engine 3, engine 4, engine 5, engine 6. So it goes down like that. One of the most crucial ones to make sure is set is the one that's set under this red guard. If that is set off, it will not start the engine. The engine just won't start without that one. So what we're going to do is we're going to imagine you're happy with that. They're all set as they need to, and we can move to the payload setup. Okay, so here we are on the EFB. Now we're going to really keep this minimal to what you need because we're going to do an EFB overview later on. So it says to go onto the ground tab, which we will do. And now we want to make sure we start to open the main door. So this is the cargo door, so we're going to do that straight away. Now you'll notice on here the sort of bar loading percentage. This shows you how far through the different aspects of the loading and opening the door it is. So first of all the door, then the legs come down, then it kneels, and then the ramp comes open. You can track that through here. Next we need to choose which payload we're going to take. If we currently have it on the none, so this is the generic cargo, what it's doing is it's taking either the weight that's in the sim, so the weight that you have set in the weight and balance tab here, and it will draw boxes in the cargo hold. If you have no payload, so 0 payload, then the cargo hold is completely empty. But we want to load one of the custom cargo loads into the aircraft. How do we do this? Well, we can select the right arrow, so we have a truck, 2 fire trucks, full airport size fire trucks, a train, helicopter, 3 helicopters actually in fact, a boiler, this is by far the heaviest payload, and back to none again. So today I fancy going with the train. So as you can see, when the door is open, you can click load cargo. You should really wait for the whole process to finish, but fair enough. So I'm going to click load cargo. So now this is actually in the aeroplane. That's the cargo loaded. If you really wanted to, you could simply click main door, close it back up again, and that's it. But what's going to happen next is the aircraft's going to start to kneel down. Now, one thing to be aware of is when the aircraft's kneeling, the camera will not kneel with it, and you actually see the aircraft sort of moving below you. So either you move the camera with it, or when you pop back in from the outside view, you just have to adjust your head down. If you leave it in this position like now, as you can see the aircraft's going below us, what will happen is automatically the camera will swap to a knelt position camera when it reaches about the roof height. But there's unfortunately nothing else we can do about it at this time. But we felt that it was such an important feature to have this kneeling in the aircraft that we wanted it in regardless. Okay, so now we're done with the loading of the cargo. So the door's open, everything's ready. We can just close the main door. We do that by just clicking main door, and it will close up again. You're going to join me back again when the aircraft's back upright and the door is closed. Okay, so that's everything done from the payload setup. I know that seemed confusing. So just to review, we went on the ground tab, opened the door, waited for the door to open, selected our custom payload, clicked load cargo, and then closed the door again. That's the minimum that you need to do. Or you don't have to do it at all. I mean, just set the payload in the weight in the default system and you're good to go. So last section says close the cargo door. That's what we've done. So let's move on to the Autopilot nav computer setup. So we have got the Garmin GNS530, which is the working title one set up. So first of all, we need to click OK, OK, and now it will search for a valid GPS signal. And you will start to see why I mentioned earlier on the world map that it's by far the easiest way to do this. So when this has done its setup, you will notice that that full route that we had on the world map is already loaded in. If you want to do your own custom route, you'll have to program it using the Garmin here, and I'm not going to cover that because it's a generic unit, so it basically works as any other Garmin in any other aircraft would. So you can see our route is here, and if we zoom out, we've got all those different waypoints and the arrival is all in there. So that's very, very good. So that looks good. And that's basically the setup complete for that. So Captain FO Navate setup. Well, if you wanted to fly along with VORs, radials and things like that, That's where you would tune them now on the navigator station. We're not going to go through that today, as it's a bit more of an advanced procedure, but that's where you would set it. What we do need to set up though is our HSI and what information it's going to read. So down here you can start to see some options that we have. So basically these push buttons here are selectors for what to display on this instrument. So what we actually want to set is this one, nav. So this shows us the next navigation waypoint, so distance in kilometers, the course that we're going to have to it, and the deviation from it. And you can also do the same on the first officer side, but you can have it set to whatever you want, but I'm going to set the same. Now, if you can see the VOR1, and we can set it like this as well, and also you see here, this isn't doing the same. So what this does is it sets the pointer, so this second needle, to a different station, but we have nothing tuned, so it's in the park position. You might notice a few of these flags, so the K and the L. I believe one of them is for the valid DME and one of them is for a valid glide, so it will disappear if it gets that. But because obviously we're on a nav course, it has neither of those, so the flags are shown. That is normal. So moving up to the Autopilot setup. Now, this is going to take some explaining. Setup wise, it's extremely simple. So if you don't really care how it works, just do this. Set it to navigation and you're good to go. There's no other setup needed, but we need to take a moment to explain how this unit works, how we're going to interact with it in the air, and the logic behind it. Included in the documentation, I have a write-up about how this works, but we're going to basically do the same thing now, and this is going to take a while, so stick with it. How this system works is moving from top left to, we're going to go through each button basically. This one is the autopilot, on, off. So if the light's off, it's off. If it's green, illuminate, it's on. Fair enough. This is the auto throttle, so you can select it on, and what it will do is if we're in the climb, it will act as a thrust mode, and it can also act as a speed mode. That's it. It can't do anything more than that. And actually, something that we found out later on, but we've decided to still include it, in the 225, it was a function that was planned, designed, and was supposed to function, but they never got it finished in time. The program for the 225 came to an end, and they just simply didn't finish it. So it does work here, but if you want to be 100% authentic to the real aircraft, it didn't actually function. That button isn't made up, it's a real button, and was going to work the way we have it, but it doesn't in the actual 225. It didn't ever function. This is a reset. It basically resets it to a basic mode. You don't really ever use it. Talking to the people from Antonov, they said, I don't know, we don't really use it. Fair enough. This underneath here is a power switch to the auto thrust system. So if you have this selected off, then the auto thrust won't work. So it's like a power bus switch. Now, these are the ones that are a little bit confusing. So toggle wing level. That one's not so confusing. If you press it, basically the aircraft will just roll its wings level and this will be illuminated. Fair enough. This one is your lateral mode. Okay, so this does your lateral mode. So let's think about this for a second. If I have it set to navigation, which I do now, what do you think the lateral mode for navigation is going to be? It's the course that we have set in the autopilot, you know, that route that we have set. So if you take off with the selector in navigation and you click this, then it will go, oh, you want me to navigate en route, and I'm going to follow the navigation, lock onto the path, and it will follow it from waypoint to waypoint. So for the majority of people, this is the mode you're going to want to use when you take off, because there's, you know, basically no other mode that's relevant. This one here, what does it do? So this is pitch hold. So when you engage it, it will engage at the current pitch that you have. You might say, well, how do I adjust the pitch? Well, we need to move down here. Okay, and there's a few other items here. So this here is, and if you click it, you can see the degrees, is the autopilot pitch. So if I do this, see now it's set to 0.4 degrees, minus 0.2, 0 degrees. So basically, if you engage that button, you can then move the wheel. Easiest way is to just do it with the scroll wheel, and then it will actually fly that pitch. And that's actually the mode that they use the most in the real aircraft. Really works pretty smooth, pretty stable. It's how they accelerate, it's how they decelerate, it's how they start to descend. So this is a mode that's often used. This here is the heading bug. So if I move this heading from left to right, the heading bug, if we have a look up here on the HSI, so you can see it's down here. If we move it here, see how it moves? It's moving the heading bug on there. So that's where you control the heading for the aircraft from, is here. This is the bank selector. If you move this at any time, it basically will just hold the bank that you set here. So if we do this, see it's going to go, well, obviously because we're not in flight, it can't do it, but it would go 10, 12, 11, 12. If you let go, then it's going to go to 12 degrees, hold it, you move the knob back, and it will roll until you see 0 degrees in that window, let go, and it will hold 0 degrees. Kind of makes sense. This is like a master switch. What do I mean by that? So remember I said that the button on the top is like the autopilot master turning it on? Well, yeah, it is, but this is how you supply power to the system. So if there's no power to it, it's not going to do anything. So at the moment you can see it's open, the contact is open, so it's on. If this is off, the whole autopilot system isn't going to function. Okay, so let's go back up to the panel. So we've gone through what navigation does. So this is pitch hold, and this will do the path en route. Approach. Now, this is where you'll start to see it's a little bit different. These buttons don't do the same thing anymore. So it's like a multi-purpose button. So if we had a valid ILS frequency set in the Nav1 radio, which we set on the navigation station, remember on there in the course, if we then select this button here, it will arm the localizer. Remember, think about it, that's the most appropriate lateral mode to do with the approach. So you click it and it will lock onto the approach. Now, think before I say, think. What do you think the most appropriate vertical mode is in the approach? It's the glide slope. So when you press this, it will arm the glide slope, and then it will capture the glide slope and go down automatically in the approach mode. So it's no longer pitch hold, it's now a glide slope mode because it's in approach. Okay, now where do you see this information? Well, here is what I would describe as the FMA, the flight mode annunciator. So basically this is where the autopilot will tell you what it's doing. It's not as clear as you might think, because often it tells you after it's done it, which sort of helpful but sort of not as well. And also there's some more up here. So there's some autopilot modes, and then the first officer has the panel down here and split up here. So it's not all the same position all the time. But that's where you can see what the autopilot's trying to do most of the time. VOR1 or VOR2, same mode, but think about it again. So what's the most appropriate mode for a VOR laterally? Well, what it will do is if you have a radial tuned and you click that button, it will automatically lock onto the radial, kind of like a localizer, and fly towards it. This does pitch hold again, because there is no vertical mode with the VOR, is there? So it just goes back to, oh, I do pitch hold, fair enough. Now, course 1 and course 2. These, I don't really understand why there's two of them. I'm sure there's a good reason, but I don't know myself. But let's say you're in course 1. Course 1's the one you want to use nearly all the time. So how do we fly a heading? Because remember I said there's that heading bug down there. Well, how do I get it to do that? Well, you have to be in course 1, and then you set the heading that you want on here. Up, say it's that, which we can see is set on here. Fair enough. And then you click lateral. So it's the lateral mode for course 1 is the heading bug. So it will basically, you put the heading in, press this button, and it will laterally go onto the heading and roll out. And that's how it does it. Okay. It might seem overwhelming, but once you start to understand this, it makes sense. It's a logical system designed logically. It's just a bit different from what I was used to and other people might be used to as well. So let's continue. That's the hard bit done, okay? Sort of. What do these, and these do? Well, this is called they call it speed stabilization. Now, it's sort of wrong to call it level change, but that's what it is. So let's say you take off and we want to accelerate, and we are in navigation mode. So a very appropriate thing that's going to happen to us. We take off, put the autopilot in, we press this button, navigation, fine, we're en route, and we're in pitch hold. Okay, great. Now I move the pitch down a few degrees, so then the nose comes down, and the plane will start to accelerate. I get rid of the flaps and all that sort of stuff. Great. Now I'm approaching 250 knots, or something like 300 and 400 kilometers an hour. And now I want to climb up to the altitude that I have set in this window, because this is the altitude we want to go to in meters, remember, not in feet. So 2,000 meters. What you'll do is when you are at the speed you want to climb at, you press this button, speed stabilization. Then what it will do is the plane will go, that's what speed you want. And what it will do is this window here will then become that speed, and it will pitch to maintain that speed, just like a level change. Why is it a bit different? Well, if you decide, oh, actually I want to speed up to, say, 500 kilometers an hour, something like that, that isn't going to work, because it's not designed to do that. It doesn't have any acceleration or understanding of that it shouldn't pitch down, and it's just going to pitch way down to try and capture the speed. And that's not what they do in the real airplane. What you would do is you would go, I want to accelerate. Put it back into pitch hold, reduce the nose down again, so then it pitches down, it accelerates up to 500. When you reach 500, you click, bonk, you click level change, and it pitches back up again. And then it will climb at that speed. And that's how you accelerate and slow down in the most realistic and smoothest manner in the 225. So, what does this do? Well, it does the same thing as the button below, but in Mach. So, because think about it, if you're always climbing in indicated airspeed, that's not going to work when we get to the higher flight levels where we want to climb at a Mach. So what you can do is when you reach the speed you want to cruise at or you want to climb at, and you press this button, click, it will target a Mach, not the indicated airspeed, and it will climb at that Mach, or cruise at that Mach, for example. So that's what this mode does. This one is just the altitude light to basically show that it's going to level off. It goes blue when it's on. That's all it does. So altitude stabilization, it's stabilized at that altitude. We're nearly there. There's a few more modes. So moving back to the left, because I want to explain the main bit first. Here we have vertical speed, basically. So you can set on the wheel up to, and these are in meters, remember? So again, it's easy to use the tooltip, because you can see it goes up to 10 meters per second, which is 2,000 feet per minute, I believe. That's what it is. So you can set the vertical speed on here and click engage. Now, when you do that, there isn't the easiest indication that you're in that mode. There's no FMA, no annunciator, so just be aware that it can be easy to accidentally be in vertical speed. And what it will do is it will sync the vertical speed to the vertical speed that you have when you engage the mode. The wheel will drive itself to that mode and will engage like that. Okay? And the other one here, this synchronizes your current altitude in meters to this window here, and it will level off basically because you're pressing the button. It goes, oh, we're at that level, level off. Not the most useful mode in the world. I mean, if you get told by ATC, hey, level off, click the button. But it's a bit slow anyway. But that's what that does. Okay. Take a breather. That was complicated, very complicated. Let's move to the right, where things are going to get a little weirder, but they're not as relevant. This panel on the right, the Autopilot control computer, it's cool, but it's not really used much, and it's also not the most relevant thing. So let's go through it. So what is this? This is effectively like a digital display of what the plane's doing. So TAS, GS, so just go through it one by one. True airspeed in kilometers, ground speed in kilometers, the autopilot, so remember this speed here, in kilometers, your indicated airspeed in kilometers, This one is just showing that it's like at the park position, sort of like the bank that you have. So B bank. So 0 bank, right? So if you're banked at 12 degrees, it will show 12, which helps when you're setting the bank selector, remember, because then you have a digital readout on here. And your mark, basically. So this is just how you view what the autopilot's doing. This one here, what is it? So this is, I believe it's your radio altimeter in meters. That would make sense. This is what you have set in the autopilot panel. So 2000 is there. And then this is your current altitude in meters. That's what it is. So you can see it matches our altimeters, right? So that's what that is. On the left side here, we have digital readouts of what the navigation is doing. So we have, let me just go all the way to the left here. If I scroll to the right, so that's VOR1, VOR2, NDB1, NDB2, and these are sort of like just park positions. And that's what they do. So what does this stuff do? Some of this stuff is pretty weird. I will be honest, it's a bit weird. It's fascinating. I honestly don't know how often they use these modes, but they're there. So, turn 90, and these ones here are the main ones. So, if you click this button on, see it goes green. So you've enabled, I want to turn 90 degrees. And if you click to the left, now what it will do is it will automatically set the heading bug 90 degrees to the left. Remember, you must make sure you're in course 1, and then you click lock onto it, and it will basically just turn the plane 90 degrees to the left. You can go to the right, and then you have to re-engage this, and it will turn it 90 degrees to the right. Okay, fair enough. If you don't have the turn 90 button on, so you just say this, and then you click in course 1, remember, the lateral mode, it will just go around in circles endlessly, left circles. And if you have right selected, you must then reselect this, and it will go around in right circles endlessly until you deselect it. I don't know how useful that mode is, but it's there. It's pretty cool. It's pretty odd, but it's there. This one is max autopilot pitch. I think it limits it to, I can't remember now, it's maybe 45 degrees, but it doesn't, these have no function, and these are the match pitch and max bank. You can select them on like this, and I think they would often fly with it on because it will obviously, otherwise it will just disregard the bank limit at all. But with what we currently have, the autopilot won't command over 30 degrees anyway. But in the actual aircraft, these will stop it going way outside of limits, but I don't believe that it's often really used in the real aircraft because it was only a kind of an obscure mode that could actually ask for that. Not the Nauto in heading, for example. It wouldn't just go straight to 45 degrees if you didn't have that on, and if you had it off, it would just roll upside down. It wouldn't do that. It was for a specific mode, but the buttons are there. And that is basically the entire autopilot. It may seem confusing, but remember, all you really need to do, if you just want to do a flight, navigation, take off, put the autopilot in, put this in, increase, put the pitch hold on, lower the pitch down, increase the speed that you want to climb at, put it into level change, it will climb. Then when you get into the cruise or a bit higher up, you can just change it to Mach and you're good to go. And then if you want to descend, you can set the altitude down. Again, level change will now bring you down in idle, and then or you can use vertical speed, like a normal plane. I don't need to explain to you how that works. So it will take a bit to get used to, but that's it. All right, so let's move on to the engine start, because now we've got it set up, remember, we just need navigation, we're good to go. So beacon light switch can come on, engine start cover. Now the engine start cover, that's interesting, it's on that 90-degree panel. We open the panel up, we make sure that these are set to rich. Now we make sure that these are selected to on. So you can make sure they're unguarded, or like this, and you make sure that they're on. Hydraulic transfer pumps we put on temporarily, and then the engine status is fine. Then we turn these back off again. FADEC switches, we need to turn these manually on the top left here, and the auto start button press. So let's talk about for a moment what this is going to do. So when we press this button, it arms the automatic start system to say, hey, I want to start all of the engines. Okay, so this is why this is the auto start engine checklist. Now if we were using the manual checklist, you would say, hey, I only want to start engine number 3 or number 4 or number 5, blah blah blah. But we want to start all of the engines in one go. And what you do is then you press the start button. So now we're going to press and hold. You have to press and hold it for about 3 seconds, I think. And you can see launch in progress, start valve 1 open. And now what we can do is we can go and check out what's going on up top by the engine instruments. So now we've got the N2 is increasing up. And what the auto start sequence will do is it will go engine number 1, engine number 6, engine number 2, engine number 5, engine number 3, engine number 4. So it goes like outer, outer, inner, 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 basically. See, it's starting automatically. This is how the real aircraft works. So it's a pretty sophisticated system. You don't have to, you just monitor, make sure that it does the right job, and that's it. So we can watch this one start to introduce the fuel shortly. We should see the EGT start to rise. There it goes. See how it starts to increase on the inner. So this is like up to 100, then these are the hundreds. Starting to increase. And this takes a while. Because there's 6 of them. It takes a minute and a bit each, 6 or 7 minutes of just sitting here. So you can come back to me when all the engines have started. Okay, so the engines have just about finished now, and we can see all the engine fail lights have gone. So we're waiting for this. This is all done now. So auto start button rest. We press the button, wait for them to start up. They've all started up. That looks good. So now we can go to the hydraulic switches. Remember, we must turn them on, otherwise you don't have any hydraulic power. So on, and on. And can you see they take a little bit, and then the hydraulics power on, and we get some pressure up here. Then we can close all the guarded switches, and now what we can do is we can close the engines there, and now we move back to the electrical panel and we make sure that we turn the engine generator switches on, because at the moment, remember, the APUs are still running the electrical system. So if I turn it on, and you can see now we have a strange situation where we've got this and this symbol. So this means APU, this means onboard. So onboard either from the ground power unit or from the aircraft's onboard power. And that's what's going on right now. So we've selected those on. Manual engine start is exactly the same thing, but remember, you select the engine, you press the start, and then it will just start the engine on. So we go back up to the APU. We press the stop button. Now this just turns the APU off, and I'm going to do the same on the right one. And what it does is it just sends a stop signal to the APU, and it will just start to shut down. That's it. Alright, so now we just wait for the APU to shut all the way down, which it's nearly there now. It's pretty close, it's close enough. So now we make sure that the fire loop goes off. Right fire loop goes off. Lead goes off. Lead also goes off. Left master switch goes back like this. Close this. Right master switch goes like this. And let's say you close it like that without doing the switch, it will put the switch in the correct position. Flap lever, we now set this to 2 degrees. We're really getting somewhere now, right? We're setting flaps. Woo. The ground spoilers, we make sure we armed. So remember that if that's at the 0 position, you can see there's kind of a D10 there. So armed. Thrust lever lock handle, we go up, and we will come to this reverse thrust in a moment. It's unusual, let's put it that way. I mean, it's fascinating, to be perfectly honest. Okay, flight controls free and clear. So obviously you can just move them and you can see them move like this. The other place that you can go is down here. So this is like your flight control setup. This is the flaps and the slats and the spoilers. So we can go all the way this way, to the middle, all the way to the right, back to the middle, pitch, all the way up, back to the middle, all the way down, back to the middle, rudders, left, and full right. You can see both of them move. Now interestingly, the 225 is flubber wire. I might hear you going, what? It's like, it is fly-by-wire, but maybe not in the sense that you know. It's more of a conventional fly-by-wire. So when I make a movement on the control wheel here like this, it just directly translates via a wire all the way to the flight control that moves it. There are cables as a backup, but the primary way to do it is with this, which is fully fly-by-wire, which is really, really interesting, especially for the period. And talking to the people from Antonov, they said flying it with the cable backups it's not like a one-to-one, it's bad. It doesn't fly the same as when you're on the fly-by-wire. So that's done. Aileron and rudder trim, this is here and here. This is the pitch trim indicator, this is the rudder trim indicator. We can also use the tooltips to see like that. Nose wheel steering switches, they're on by default, which is fine. You can turn them off there. And the taxi lights, we can put this to retract, so that actually retracts the lights. So we can go to extend, and then we can put the taxi light in. This is the landing position, this is the off position, and this is the taxi position. Middle off, down taxi, up for landing. Okay. So we'll leave it in the taxi position. Logo lights can come on. Interestingly enough, the logo lights are on the end of the wing, angled inwards, and they shine a light on the logo on the tail. It's really fascinating, but that's in the sim as well, which is pretty cool. Alright, there's a few items I want to talk about when we're on the ground here, because I think doing it in the air is going to be a bit confusing. So first of all, let's talk about this reverse thrust here. Alright, so how does this work? Well, this is a bar that you put up to allow you to deploy the reverse thrust. So how does it work? Well, if you set the thrust levers to below idle, so they go below where they are now, what that will do is start to unlock the thrust reverser doors, but it won't actually give you any reverse thrust. It's like idle reverse in Airbus terms. So if we just hold B on the Xbox controller, it will automatically do this process for you. You don't need to worry about it. This is more for an interest. But if we try and interact with it with a mouse, so if I drag this down now, do you see how this has jumped down? We're unlocking the reverse doors, but we're not getting any N1. Now if I keep moving this, now do you see how we get more N1? Now we actually have reverse thrust. A bit more. And full. So now we've got full reverse thrust basically. But if I then stow this, see how it jumps back up? The reverse doors stow, and now we don't have any. Interesting system, but that's why you must make sure that the bar is up, otherwise in the real aircraft you can't pull it to actually activate that. And it is quite an awkward mechanism in the real aircraft. Well, it seems to be anyway. Talking to the people from Antonov, I think they indicate the same. Next we're going to move over to the landing gear, because this is, I mean, I'm going to say it's unique, but it sort of isn't. It makes sense. You've got these, so you might see, what are these? Okay, so the thing that you might be looking at to go, that's odd, is the landing gear is in the middle but on the ground. So it's kind of like how the 737 works. So let's imagine we're doing our takeoff, which we're going to do. We take off, positive climb, we're at 10 meters, we select the gear up. Now if we just grabbed the catch and tried to move it up, it isn't going to work, it's locked into position. So what you must do is safety catch open. I'm not going to do it, quite obvious reasons. Click the gear up, and then what will happen is, okay, the gear doors will open, the gear will start to come up into the aircraft, up, click, and you'll know it's into position when the green light goes out. And also, all the way back here, you have a selector showing you all the different wheel positions. So when that light goes out, then you know that the gear is up and locked. So then you put the gear back into the middle position here, and you close the safety catch. So you'll fly around in flight like this. This one's a little bit more unusual. When you come to land, you open the catch, and I will do this because it won't do any harm. Select the gear down, so then the gears start going open, it's coming down, click, then we'll get the green light, like we get on the back here, we get there, and we know the gear is down and locked. Then you move the gear into the middle position again and recatch it. So you actually land with the gear like this in the neutral position, which is pretty interesting. You basically just turn the pump off, turn it on, put it into neutral again. Makes sense, but at first sight it looks a bit odd. If you use your key bindings, so toggle gear, it does it for you automatically. It's going to open the catch and put the gear up and then recatch it as well. But if you're interacting with the mouse, this isn't going to actually allow you. You need to actually do the safety catches properly. Next, we're going to talk about the engine gauges here, because they may seem simple, but they're a little different. This one on the left, I would call it an engine power request gauge. That's probably not the best wording, but hey ho, that's what I'm going to go with. So this is asking, I want this much power, and the right side is showing the engine N1, so the actual power that you get. So let's try this. So for example, if I move this up, can you see how I'm asking for 30 odd, 33, 30 whatever percent power, but that equals 40% N1. So it's not a linear scale. And also you'll notice that this goes up to 120. So 120 is full power requested, and around 98, 100% N1 sometimes, it goes over a little bit, is full power. That's full N1, right? So let's try again. So I move this up a little bit more. So you can see how what you're requesting, it's not quite a linear scale. But that's how it works in the real aircraft. And if you go onto the back panel here, that's what you will see drawn here. Not the N1, but the requested power, basically. Anyway, it's not super relevant, but that's how that works. Okay, so while on the theme of the engines, let's talk about these switches here. They're pretty interesting, so let's just turn them on. So what they do, can you see these lights come on up here? And they actually increase the idle when you're on the ground, or in the air. You can use it in the air as well. And I believe the reason for this is to stop build-up of, they call it coke in the engines, like sort of like soot, bad description. And it stops a build-up of that running at a super, super low idle all the time. So you use these primarily when you're on the ground. It also helps you taxi around, because in this N1, it's pretty easy. 30% N1, it'll roll basically at this higher idle as such. And remember, you can turn these on and off, see how they're paired to different engines. And if you want to, you just want to get rid of it, you close the guard, they will get clicked forwards. Yep, so that makes sense. Okay, so what we want to talk about next is the airspeed indicators, and generally what are all these different gauges doing. Alright, so on the left side, starting from the left side, this is, I would call it like your backup VOR ADF. So if you have one tuned, this is just going to point to it, the park position. So you can do that for VOR2, ADF2. This is your DME setting. You can see it's off. That's as per the checklist at the moment. We talked about these already. This is your primary airspeed indicator. Blue is your rotation speed. It's based on your weight. You don't have a V1 speed. We don't have the information for that in terms of field length versus stopping requirement. So you're going to be operating the 225 from a pretty big airfield anyway, but that's your rotation speed. This is the basically maximum speed that you can go, and this amber pole here is like your maximum speed with your current configuration. So if you move the flaps around, then this pole will move, showing you what your maximum current speed is. But this is like your overall maximum speed. And this is your airspeed indicator, so if we move this down, for example, it moves the bug on here. This is your pitch indicator. You can turn it off, cage it. This is your TCAS / vertical speed indicator. This over here, this amber is beta, and this is your slip indicator. There's also a climb in meters per second. This is your radio altimeter. It's a small test that you can run, doesn't do too much. And this is where you set the minima. So you see the little amber arrow, when you move this is how you set your minima. This is a altimeter in meters. Interestingly, the pressure set is in millimeters of mercury. So 760 is like 1013. So see. So again, it's how it came fitted. This is your horizontal situation indicator. We've talked about the settings on here a little bit, so you can display different things on it. This is another altimeter in meters. This is your parking brake test. This is a clock, and this is your angle of attack, and this is your G. in G load. And on the other side, it's the same thing. Okay, so those are the primary instruments. Now we're going to continue with the checklist, because I think that's a pretty good overview of what you need to know, where it is, how the autopilot works, how we're going to engage reverse thrust, and we're going to continue. So, next thing is the lineup and engines run up. So we're going to taxi straight down here, and then we're going to go onto 26 left, and we're going to take off. So let's talk a little bit about what we're going to do when we line up on the runway. So, we've got line up as required. We're going to put the strobe lights on, which makes sense, and then we're going to set the parking brake when we're lined up with the runway. Then we're going to start the engine warm-up procedure. Now this is quite unique. So what we have to do is we have to run the engines at idle for 2 minutes, this higher idle, these buttons pressed. Then we're going to set 70% N1, so that's 70% shown on here, and we're going to hold that for 2 more minutes. Then, when that's complete, we're going to put the captain DME bus on, captain window heat on, first officer's DME bus, first officer's window heat on, and then the fuselage and wing light on, and then we can take off. Finally. But one thing we've got to set first is our first stop altitude, so we're going to be going up to 5,000 meters today. So 5,000 meters is our cruise altitude. So, let me collapse these down and talk a bit about why are we doing this engine warm-up. Now, the reason we're doing this engine warm-up is to make sure that all the engines are heated equally, ready for takeoff. Okay, so we've got quite a tight turn going on here, so I'm going to keep the speed pretty far back, and I'm going to show you how manoeuvrable Maria can be. So here you go, I'm trying to feed in the tiller now. You can see the tiller takes 270 degrees to go all the way around, so it looks like it's quite active a lot of the time. But look, we're quite comfortably making this turn even at idle. So it may seem like a very big aeroplane, but it's pretty manoeuvrable. I mean, it really doesn't feel that unwieldy given its size. You have to be obviously very careful with widths, and also the fact that the wing at the moment will be overhanging the edge of this taxiway. You have to be pretty careful with that. Like, I have taxied down a few taxiways and gone, oh no, there's a building in the way. I can't go down here. And then you look at the chart and it says that you can't go down there. And you go, oh, yes, whoops. Okay, so we're lined up now. Put the parking brake on, as we talked about. And then we're going to put the strobe lights to on. And we're going to make sure that the parking brake is already set. Engine warm up. So we are going to make sure we're idle, and now we sit at this higher idle for 2 minutes. So we just wait now for our 2 minutes. Okay, that's complete now. So now we increase the thrust up to 70% N1. We do this slowly. Yeah, it's close enough. And now we sit here for another 2 minutes waiting. Alright, we've had our 2 minutes now, so after warm-up complete, we make sure that we set the captain DME switch to on, and then we make sure we put the captain windows heat switch on. I'm also going to put my fan on, just because I can. I'm going to put it on the window like that. First officer DME display bus, I'm going to also put that on. And I'm also going to put the window heat and the FO fans on as well. Fuselage and wing lights, this can come on as well. So now we are all ready to go. So we move straight into the takeoff. Flaps, we can now set to 35. 35 degrees of flap is now set. So what are we going to do? We can stow these away, we don't need the higher idle. We're going to be setting full power, so basically about 118% on this selector here. Release the brakes. We'll release the brakes first, set the full power, keep on as we're rolling, and then rotate once we get to this little blue marker here. Then at 10 meters, we're going to select the gear up. We're going to do this with the mouse. I'm going to try and do all the interactions with the mouse to show you what they look like, rather than using the keybinds. And at 50 meters, fuselage and wing light and taxi light go off. And then we will move into the climb checklist. So, ready? I'm ready. Let's take the brake off. Slowly start to increase the power up. go. Thrust is set. You can also see your airspeed and knots on the backup here, on the ISIS. Okay, we're getting there, getting there, getting there. Blue marker, very small rotation. You can see the nose is virtually lifting itself off the ground now. I need to trim a little bit forward even. There we go. Trimming forward, getting it nice and stable, and starting to turn en route as well by looking at the HSI. So there we go. So now I'm going to do the gear. So we've got a positive rate of climb. Remember, safety catch off. Gear selector up. And we've got 50 meters. So I'm going to start to try and roll out slightly on this heading. That looks good. The gear's coming up. Okay, we're at 50 meters. So now we can put the fuselage light off, which is here, and we can turn the taxi lights to off as well. Okay, trimming nose forward, that's because I want to start to do an acceleration. Not quite that much forward, a little bit more, a little bit less. There we go. Right, so I'm going to do something now that might not work out. It's going to put the autopilot in, pitch hold is engaged, and I'm going to wind the pitch down a fair few degrees to start acceleration. There we go. I'm starting to accelerate. So, gear is now up. See, the lights have gone out, so I put the gear back to neutral and close the safety catch. So we're accelerating, one stage of flap up. Here we've got a good level of acceleration. Next stage of flap up. I'm going to pitch the nose up a little bit. Okay, accelerating again. Flap up. And we're approaching again. And if you want to see where these speeds are from, we have them written in here as well. So we're over 410, so 50. So now what we're doing is I'm waiting until we get to 250 knots, which is right about now, so speed stabilization. Okay, so now I've reduced the thrust back as we're climbing on here. One item I did miss is at the point where we're cleaning up the aircraft, we can put down the reverse handle as well. It's all in the checklist here. But I am trying to do 6 people's jobs, film, and tell you how it works, which is, it's a little difficult. Okay, so one thing I've just enabled now is I've put it into navigation. So remember, we could have done this a little bit earlier, but we were in navigation, and then we click the lateral mode, and it will lock onto this GPS course automatically. Now we're above 10,000 feet, we can accelerate. Now remember, this is just a demonstration. So if I wind the speed up, you can see it will pitch down to accelerate, but look how violently it's doing it. You see that? That is not A, comfortable, and B, it's really not good for fragile cargo that we have in the back. So let's do that again, but do it correctly. So let's say we want to increase our speed to, let's say 550, something like that, kilometers per hour. So how would we do it? Well, put it into pitch hold, come down here, you can see we're at 4.3 degrees, reduce the nose down a little bit, so see how much more controlled that is, right? So now the aircraft is accelerating, still climbing a little bit, and if we go, that's not enough acceleration, or whatever, you can go, okay, fine, a little bit more down on the nose. Yeah, now we're accelerating, and I can even remember, because we're manual thrust, bump the thrust up a little bit. So see, we're still increasing the speed. I can set my speed bug to what I want, so 525, so we can see when we get there. And you see how much more controlled this is, yeah? So we're nearly there, so I would say we're pretty much at our 525, but remember we can't even look at it here. There we go, 524, so we can see when we hit it, 525, level change. So, or as I should correctly call it, speed stabilization. So now it will climb at that speed. So, alright, so let's finish up this climb checklist. So remember, we took off, it was all quite busy. 10 meters, gear goes up with a special procedure. 50 meters, the fuselage lights go off, landing light goes to taxi. Then we start to accelerate after we reach our thrust reduction altitude. So when we get that, we start to accelerate. So we start a slow acceleration, as we said here, and then we have the different speeds here. These are for you to know, look them up afterwards when you do the flaps. I did them where I just went one after the other, after the other, after the other, and when you're quite light, it happens quite quickly, and then you end up being clean, as we were there. Throttles, then you can reduce them. It says here 112. That's kind of like a heavy cruise climb, if that makes sense. But I've put them down to 96% power here, which is also an acceptable climb power. But if you're using the auto thrust, it's just going to ask for full power all the time. Set the autopilot to nav as needed, and this is obviously something we delayed a little bit, but that's because we were trying to demonstrate the departure, where you make sure you're in your navigation mode, and then you click the lateral, and it will do this. And you can see we get the autopilot on nav and course stabilization written down. So we're coming up to our level off, and you might say, well, how do I know? Well, first of all, here we have what our current meters. We've also got our meters here, and we're going up to 5,000, and this is feet as well, and this is our feet. So plenty of altimeters to choose from. And the aircraft will level itself off automatically. You can see the blue lights come on to show that it's capturing the altitude, because it's stabilizing the altitude automatically. I'm now going to put the auto thrust on. Altitude is showing up on the FMA here. I'm going to call it the FMA, I actually don't know the proper word for it. And now you can see we are at altitude. And that's it. We are now in the cruise. Okay, so now you might say we can move on to the cruise checklist. So when we approach the cruise, this is, we just follow the route, we check the fuel on board, and we set the cruise power. We've done that with the auto thrust. During the cruise, we can make sure we have this selector set to what we wanted, which navigation is what we want. And before descent, we need to set all this up, which we're going to come to. So it's kind of, the cruise is like a reminder, which is fine. So how do we know when we need to start to descend, top of descent? Of course, you can just use the old school 3 times table, calculate it back from DMEs, radials, all this sort of stuff. That of course all works, but we can also look a little bit more into the Garmin. Okay, so let's have a look at the VNAV function that we have in the Garmin here. So we can say we want to be 3,000 feet. That sounds good. 4 miles before sounds reasonable. And remember, we said it was that waypoint Orviv. And our descent rates, I think we'll probably be able to achieve around, this depends obviously on weight, but 1,700 feet per minute should be doable. And now can you see, we get a timer so that when we need to start our top of descent, so in 7 minutes 30, we need to start our top of our descent using a vertical speed of 1,700 feet per minute. Now that actually is, I find it really helpful. This is all the fantastic work that the working title team have done. We didn't integrate this. This is a real feature in the real Garmin, and you can use it not only on a light aircraft, but also on this aircraft. It works just the same way. Okay, here we are at the navigation station. So we can see pretty much the same sort of information with altitude, climb rate, clock, Mach gauge, radio altimeter, but we need to make sure that we tune our ILS here. Now, where can we find that frequency? Well, we can find it on the charts, or what we can do is we can scroll through here, and we can click on here, and we can see, remember we said that we were going to do the runway 25 center as well. That's fine, it's a bit longer. So we can do the ILS 25 center, which is 111.550. So let's put that in, 111.550. So it's a bit of a change of the plan to change the 25 center, but it's a bit of a longer runway, and I'm absolutely happy with that as well. So the course is 246, which we can set up here. 246. So now we have this set, so when we get closer, this should auto-ident itself on here. We can read the ident and know we've got a good ILS, but we're a bit too far away for that. Let's try another one. So let's try any other navigation that we could try. Let's try the Foxtrot Romeo Delta. So that's 115.9. And let's have a look on VOR2. Nope, still not quite picking that up yet. If we did, we would display it on here, and if we had VOR2 selected, it would show the distance, and and this is where the course you see is set for VOR2, and this one is obviously set to the ILS. So that's fine, but we'll see if that comes alive later on. Okay, so when it mentions that we need to make sure we have the HSI set to what we want, the moment we're following along with the navigation stuff, so we've got our distance to go and our course, that's absolutely fine. But I don't want to use that. I want to actually set this to, you see this top left one, land. So this is now the ILS frequency. So land is like the ILS. So I have that selected and ready so we can monitor it. And on the first officer side, I can set this to nav. Okay, one final thing after we check through here, we've got the MDA. Now, where did we set that? So all we do is on here, we set it and it's in meters. So for this approach, it's around 60 meters. So we set this on the radar on this area here, or we can have it called out manually from the altimeter as well. But we will actually have an automatic call that says minimum, minimum, to let us know this is the minimum. And now you must go around if you don't see it. Okay, so we just got given the message to send to target as we're getting near the timer now. So obviously we could do this in level change or pitch hold, but now we're going to look at how do we use vertical speed. So we're going to be going down to around about 900 meters. And now we engage vertical speed like this, and now we set, slowly set I should say, because it's not that smooth. Gently, minus 1700. There we go. And I've done this with the auto thrust on now to show you how it will automatically respond. And there we go. And now we're going down at 1700 feet per minute. Alright, so what we're going to try and do now is we're going to imagine we were given a direct to Orviv. So because I want to try and show you how to do that with a Garmin, and also how we can descend a bit quicker. So let's go now. Okay, so we want to go on direct to. So we can go on the flight plan. We can push it, and then we can find Orviv and click direct to, and that's what we want to do. Execute, activate, and you can see the aircraft's now going to automatically do that. And now we can look at the VNAV, and the VNAV is saying, hey, actually you need a fair bit more descent route. So how can we do that? Well, what we can do is we can go level change. So now see how the thrust is going to come all the way back down to idle, and we're going to descend. And like I say, level changes in descent, they don't often use it. They use pitch hold again to gently increase it down, because now you can see it's just going for the speed target, and it will maintain it. It's just not the smoothest machine in the world to do this with. See, so now we're holding about 2,000 feet per minute. 1,800 is pretty much what we need actually. But we're coming up to a deceleration. So now I want to decelerate, and I'm going to do it properly. Okay, here we are decelerating using pitch hold. So just put it into pitch hold, wind it back a little bit. So now it's just slowly decelerating. You can see how I'm flogging a dead horse here now, but you can see pitch hold really is the way to go. And that's how I've noticed how they do actually fly with an aircraft. And we're going to decelerate down to about now. So this is around about our 250 knots. And then we could, if we wanted to, we'll show it again. We'll make sure that we're at the same speed here. We'll click speed stabilization. You can see how woof, it's a bit of a violent pitch down because I'm trying to get back on the speed, but we're now going down at idle. Okay, so now let's imagine this situation, sort of similar to what we've got now. We're a little high and we want to descend a little quicker. So how do we do that? Well, we can start to use some speed brakes. Now, you have to be careful with these speed brakes. So even that amount, look how much extra you get with the descent rate. Now, from Antonov, they told me that if you go all the way to say 60 degrees when you're in flight, you actually, if you just say, let's say you just grab the lever now and went bang, straight back to 60 degrees, it would literally rip the spoilers panels off the plane. So, use with caution, and only up to 45 in flight, only up to 45 in flight. And you can really see when you start to get them out, the angle of attack all starts to increase and the plane becomes extremely unhappy, which that's why you just don't ever put that much out in flight. Alright, so we're looking good now. So remember, if we just push these away quickly, that's bad. So we just slowly take them away like this. And you can see it starting to pitch back up again. And then we put it back into the arm position. See? No drama there, it's absolutely fine then. Right, so the ILS has come alive, so we can now see that we've got our distance in kilometers and we have our course set here, so that's looking good. So we're pretty much on, say, an approach heading now. So what we can do is we shortly will be leveling off. So what we can do is we can put it into the approach mode. And now remember, we can arm the localizer. So now the localizer is armed and we'll just wait for it to intercept that. And I'm going to start to bring the speed back. Go, maintaining 900 meters, speed's coming back. First stage of flap. Second stage of flap. Alright, let's do the gear. It's as simple as we had before, so safety catch open. Gear down. Keeping an eye on angle of attack at all times. A lot of drag comes from the gear. A bit extra speed. A bit more flap. We can see the localizer's coming alive. So shortly we should expect the aircraft to start to turn itself automatically. A little bit of turbulence going on though, as you can see. There we go, and now we can see it start to turn, just a small correction on. So now we're established on the localizer, we can arm the glide slope, so which is this button here. Because we're in the approach mode, that does the glide. And I'm just going to leave the aircraft in this configuration until we get established on the glide, and then I'm going to put the flaps all the way out. Okay, so here comes the glide slope on the HSI. You can see it's going to start to intercept it now. Alright, so we're on the glide now, so I'm going to set my final flap. I'm also going to set the reverse bar up. Okay, here we are, we've made it this far. The gear is down, full configuration, and now we can move to the landing. Reverse thrust, we check the bar is up. Braking is as required. Ground spoilers are armed, and the engine switches, we can put these to a high idle. So that's done and completed. So let's disconnect the autopilot now. Going to start to trim forward a little bit because I took it off when it was doing a correction. It wasn't the smartest move in the world. And I'm also going to disconnect my auto throttle because you definitely can't land with that on. There we go. So actually it's a very, very stable aircraft on the approach. You can see here, look, I'm doing quite large inputs and not a lot happens. So key to this is just keeping it as stable as you can. So trim is quite effective. You can start to hear the GPWS there calling us out. Different altitude heights. That was the 300 meters. I'm just going to do quite a large correction to get us back on the glide. Holding about 1,000 feet per minute so we get back on it. Okay, 2 whites, 2 reds. So that one is for, I think it's 100 and something meters. There we go. Now I'm going to hold it about here. Tend to always come in a little low, it seems to be. If you check out some YouTube videos, I think it might be the head height or where the plane is, but it tends to do that. There's the minimum, so we're going to continue. Flaring, not much of a flare. It's actually, you come to idle quite early, so we're going to start to idle now. And then we do a very small check, like this. Very small, hold it off, hold it off, hold it off, hold it off, hold it off. And there we go, we're down on the ground now. You can see, quite an easy aircraft to land smooth. So we're on the ground, and now I'm going to do the reverse thrust manually to show you, remember? So we click and we drag it, we go into full reverse. I haven't touched the brakes yet. Now we can use the reverse thrust down to 170 kilometers per hour, and I'm just going to use the maximum use of reverse thrust without wearing out the brakes. So So approaching 170 now, we go reverse idle. And I'm going to start to get onto the brakes now. Braking, 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 gently, gently, gently. I'm not going to go for this exit, the next exit. I'm going to go for... Where am I going to go? Now this is where you have to... A little bit of a different skill. We're going to go to the left. So we're going to take this 90 degree. We should be okay for that. Yeah, we should be okay for that. Okay, when we turn past it, and then we start to turn. So after landing procedure, I'm just going to come to a stop here. We're going to run the after landing procedure. So landing lights, they can come to off. So landing lights off, and this can come from the landing position to the off position. Captain heat switches could come to off. So they are the window heat switches, so we can turn the fan off as well. The heat switch is off. Captain DME display bus, that can come to off as well. Same thing on the first officer side, we can turn the fan and the window heat off, and the DME display bus can also go off as well. Thrust reverser lock handle can go down, and the flaps can come up to 0. Now APU 1+2 start. I'm not going to run through that full procedure because we talked about it earlier. I'm just going to do it as I know how. I'm going to start number 1. And then once number 1 started, I'll start number 2 while it's taxiing in. So let's go and cross. Okay, let's start the second APU. We are simply going to park nose in over there by that cargo area. Okay, so here we are in our parking position. So what do we have to do? First of all, we make sure the parking brake is set. So this down here. Pull and then twist up. All lights off. This is checked that all lights are off except for nav and beacon, because the beacon light stays on when the engine's running. So let's go do that now. So nav light stays on, beacon light stays on, logo light goes off, strobes are already off because we left the runway, fuselage lights goes off, and then we make sure that this is off, and we've already set this to off when we vacated the runway, because this is where we would set from landing to off. Instrument and navigation switches, so those are the ones back here, remember? So we make sure that we turn all of these ones off. So we're basically just powering down the electrical setup. So fuel and hydraulics shutdown. So let's go to the engineering panel, which is over here. So now what we're going to do is, this looks complicated, right? Off, 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 on, off, 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 on, but I can keep it simple for you. We're going to turn off all of these fuel pumps other than these, because if we turn this off, the engine will shut down. So basically we're just going to go through it like this, and we're just powering down all the pumps. And this, you're going to say to yourself, well, how is the engine still running? Well, it's called gravity fuel feeding, because the tanks are above the engines, so the fuel can feed into it, so it doesn't actually need the fuel pumps, but they're there to stop starvation. We're on the ground, which is fine. Hydraulic pump switches, so those are located here, so we can unguard all of those, and we can turn them off, 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 off. And then the fuel valve switches, which are the rich ones, which are here, we make sure that they're all set to on still, because these are like, if we turn these, if we bring these down, then it's going to shut the engine off as well. So now we move up to the engine anti-ice, and we make sure that these are off, oops, not stage too far, off and off. And APU generators, we're checking. So what are we checking here? We are checking that, remember, we have these green lights and that at least one of these is on. So we don't need both, but you need at least one. I started both just to show you how to start both. So they're there, which is fine. So when we turn the engines off, the systems will run fine. Set engine generator switches 1 to 4 off, so we can turn these off now. So you can see, look, we're now disconnecting the engines from the electrical system. The APU has taken over and is running it automatically because we made sure that they're already on. Now what we're going to do is we're actually going to turn the engines off. So how do we do that? Well, we unguard all of these switches, because remember these are the fuel switches, and we go 1, 2, 3, 4, 5, 6. And now all the engines will start to spool down, and we can see that here, and we get the engine malfunction lights. So now all the engines are turned off. So after engine shutdown, and I'm going to go through each of one of these like the little view because it's easier to follow along now. So if this one can go off, this one can go off, and if this seems familiar, this is basically the reverse of what we did when we were setting it up on the ground in Leipzig. And we just move across to the first officer's side. Do this. Oops, down here. And the radio bus. And nav 2 bus. So many switches. I'm doing this to highlight it so you can kind of see what they're called as they go along, and all 3 of these are the same. So we did that one as well. Now set nav switches to off. So remember, now we do this one off, and then we want to turn the beacon light off because the engines are now off. So we don't need the tip lights on, we don't need the beacon lights on telling ground crew don't come towards the aircraft because the aircraft shut down. Okay, so now we come down to powering the electricity down from the aircraft. So rectifier toggle switches, we turn these to off. Transformer switches, so they're behind here, we turn these off as well. APU stop button, so we send the stop command to the left one and stop command to the right one. And now we wait for them to shut down. So you'll join me again when they're pretty much shut down. Okay, so they're shut down now, so we're going to turn this off, same as before. I remember we said we can just click the catch on this. APU right fire loop, we make sure we turn that off. We close the catch on that. We can close both of these as well, and making sure the bleed is off as well. And we're basically APU left master switch. We're making sure doing the same thing as before. Batteries. Now, once we power these to the central position, so the off position, the whole aircraft is going to go dark. So let's do that now. Off, 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 and off. And there we go. We can hear, or not hear, as the case may be. Now the aircraft is completely shut down. So we have no electrical power now. Okay, so here we are, unloading the cargo now we've arrived. And it is pretty cool because when you lower the ramp, the cargo's still inside. So we've actually sort of physically transported it from one place to another. So I hope you enjoyed this flight. I know it might seem overwhelming, but try and follow these steps through a few times. And I would really recommend spending a while on that section of the video where I explain how the automatic flight control system works, because that's the thing that took me the most time to get used to. But once you're used to it, it's a logical system designed to be operated logically. That's how I describe it, and it makes sense. So, thank you very much for watching this video series. We hope you enjoy flying Maria in the sim, and I know that one day we will be seeing Maria flying once again. And a little part of that is going to be thanks to everyone who gets this aircraft, gets in the sim, and enjoys flying it. So once again, thank you very much.